Thank you for coming, and let's go. That's me. I'm doing, at the moment, critical infrastructure projects, mainly for the German government and the administration, but I also did something else. I founded 2 companies, and this is my personal history. On the left side, you see the good old times before Kubernetes. And I did GitOps with Subversion before it even was named GitOps. And then in 2014, Docker and Kubernetes came, and I'm one of the contributors to CoreOS years ago. And now I'm working for the German Fricke, but this does not really make sense. So what is the most important thing we have in infrastructure? This is critical infrastructure. There's a German definition of this. So the most critical thing probably is energy. If we have no energy, we don't need to talk about data centers and healthcare and administration. So there was a rough classification on it. And this is all about the critical infrastructure. And in critical infrastructure, there are some systems where failure is not an option. This is even less an option than starting a rocket. If a rocket fails, only a handful of people are dying. If energy would fail for a week, this would be probably very clear to very, very insecure and not very healthy environment. So Grisham, this is one of my customers who is controlling the transmission grid stability. They are going all now into Kubernetes. Why should they? Actually, why should they control a transmission grid, a power grid with Kubernetes? Effectively, at the moment, they have more devices. There are lots of uncertainties. So with green energy comes the weather as a... Oh, I silenced it, but it does not obey. So with the weather, we have more uncertainties on the consumer and also on the producer side. And we have more complicated things. So this means we need more applications to control a more sophisticated grid at all. Another example are desktops. People are joking about the Linux desktop for 1998. This will be the year of the Linux desktops. Actually, we have 2 ones running on Kubernetes. On the left side, so you see OpenDesk by the German government. On the right side, you see VNC Lagoon by a small Swiss company, which is going to get a unicorn fast. So we have a lot of demand for Kubernetes and Kubernetes security. This is one example. We have heard something about Zero Trust. And we have already frameworks for the architecture. Let's say if you want to go into a governmental environment, the German officials want to have an architecture where you have a packet filter, an application gateway, and a second independent packet filter. And with Kubernetes, the links are on the slides, you can use the internal network policies as the internal packet filter, and very few people know that you also can embed more security into an Nginx controller, which is a little bit fiddling with the configuration. And then you can integrate an application firewall inside an Nginx or maybe any other API gateway. So these are examples. Unfortunately, the examples are only in German, but you get the point. We can create applications with a higher level of security, with a higher level of isolation, just by simply applying the Kubernetes principles to existing security infrastructures. Another example of me is what people always want is, yes, let's do agile, and not understanding agile at all. And then they want to go into the cloud. Yes, we want to go into the cloud. But what they really want, and they don't know about it, is this kind of automation aspect. And in critical infrastructure, and this includes any regulated infrastructure, you also have to have in mind regulations. You have to do scanning for network securities or other securities. There are existing frameworks on that, and security documents rely on that. And therefore, the American government, together with the Cloud Native Computing Foundation, created this DevSecOps software lifecycle. Effectively, it starts with the planning, so this is a good old DevOps, spiced up with security. And you see there is more security in it than the original DevOps points. It starts with the threat model, then it starts with secure coding for the developer side. And then you have security as code. You are implementing security measures as code. This might be a network policy, this might be a more sophisticated rule. And then you do statical or dynamical software analysis. Statical software analysis is free for more or less open source projects. If you use SonarQube on open source, then it's for free. If you do it on your proprietary code, a seat is up to $20,000 a year, and you need more than one seat of it. So this can be expensive, but you have to invest in it if you want. Then if you don't have the source code of the application, which is sometimes the case, you need to do a dynamical analysis of your software, which is more or less over SAP. You can do it. Additionally, you are pen testing everything manually. So really, creativity of pen testers should not be underestimated, but this is an additional feature on that side. Finally, and this is also important, is if you are in a regulated environment, you should digital sign your images. At the moment, digital signing can be checked on the other side. If you did the secure transfer to the operation side, can be done by either scanning the signature of the container by the container runtime. Only Creo does it at the moment, or you can use the admission controllers. I would prefer Creo because it's on the basic level, but admission controllers for most of you are also okay. Then you have secure configs, which means you have separated secrets and critical config maps. So if you have network ranges in the config map, it's also a critical configuration. It's not only secrets. So be careful configuring things. Secrets, tokens, passwords should be protected. Additionally, you have in Kubernetes the possibility to do security scans of the containers and security scans for the entire configuration. In the last talk, we heard about NeuVector, which is an excellent tool for this. Other tools like Kubebench or Kubescape, and there's a lot of industry around it, can do the same. At least you should use one of these tools permanently, that you are sure that the configuration in your container is secured. This includes, for example, scanning of RBAC rules. If you can detect the connection to the cluster admin automatically, you should do it. Normally, what I see, if you ask pen testers to do this, they want to have a lot of money for a simple, yes, let's run a Kubebench, and then you get a report on that. This must be part of a daily process. This makes it a little bit exhausting, and it's really an effort to do this. Patching is easy with Kubernetes. If you have a patch, you can do an Helm update. Additional security audits also should be done, because sometimes you simply have not seen a very trivial thing, so you do this all the time. And the security monitoring and alerting is the final step, which you can do with monitoring and then post all the vulnerabilities in one repository. It can be separate Grafana or even a Splunk if you want to exchange the effort for real money. And if you are done with all that, you do a security analysis. And this security analysis is fed back into the threat model. So then you start again with this DevSecOps lifecycle. This is the entire lifecycle, and I've not seen a single company who is doing it completely at the moment because it's a lot of effort, and we have to talk about how do we get the most of this lifecycle into our real applications. And that is strategy versus tactic. Oh, that's one German word. You have to explain it to the management. I want to implement DevSecOps. This is a problematic part because you know about whatever you can implement container scanning, you can talk about NoVector or Aqua or all the others, you can talk about eBPF. The management does not want to hear a single word about eBPF. So you have to address the management first. And this is the next slide. The management knows about regulations. If you are in the banking sector, you have in Germany the BaFin or PCI DSS if you do credit card information. So this is what the management needs to know. Here at the moment we have NIS, we have CIA, and then the entire strategy is DevSecOps. To the team I normally talk about tactics. So we have Kubernetes, that's fine, containers and all the little dirty details because this entire DevSecOps cycle covers 4,000 pages of documents from the German BSI, so the Office for Information Security. And this is what you can talk about with the technical stuff. The CTO is normally in both areas, so he has to translate it in a way that both sides can understand. Normally, if I do a workshop on that, it's 5 or 10 days of consulting, talk to the team, talk to the management, and then after that, the team has at least 2 years of work to do. This should scare you, 2 years of work. This is not 100%, it is effectively 20%. 1 day a week you should work of completing the journey through this model. Implementing DevSecOps is hard, but you should see some results after half a year. Especially if you are in a highly regulated fintech, then you probably understand it. It helps you to define the small and tiny steps to go there. Everybody should be on board. I said 2 years. 2 years is a hot phase, preparation 1 year, 2 years of implementing it, and then another 2 years of let's remove the dust from every corner of your processes. So this is 2 years, 20% of your workload is really hard, and therefore you have to convince the management. Otherwise, you don't get the resources. If you are not in this business which is regulated, then be happy, just earn money, make your funny applications. But then it might be, if you are in a startup, some venture capitalist might say, no, in this due diligence on phase A or phase B, we need to look into the security, and this is determining the value of your startup. And it's important, after 6 months, you should have some visible process, some visible progress. So this is this OWASP DevSecOps maturity model. You can easily use it, but all the steps are quite hard. So it starts from maturity level 1, which is, I don't shoot in my food, until maturity level 4, we have transformed the entire culture of our organization to security. And DevSecOps means, as in the agile model, in every team, for example, there should be a developer who is a security champion. Normally, developers have no idea about security. Yes, we celebrate somehow 25 years of SQL injection history. 25 years of SQL injection. So this is my argument against developers. You have learned nothing in 25 years. Universities have not taught you anything about security in 25 years, a quarter of a century. Which means there is exactly no progress. So you need developer champions, developers who understand security in detail. Not everybody must understand it, but at least every team should have access to one security champion. This is maturity level 2, I think, and then you can spread the knowledge if necessary. So this is a simple DevSecOps pipeline from committing the source code, and on the upper level is what you normally do. You build a container, push it to a staging registry, staging tests, and then you sign it and push it to production registry, and then it goes to product. But on the red blocks, do also the static code analysis, the reports, the security scanning, also reporting and alerting on that. So this is a part which is normally hidden. It does not need to be run on every commit, but daily, at least weekly, you should run these security checks. It can all be automated, but it's some effort. This is an example of an online pharmacy. I did it for the company you might see on the top. So it's on the upper pipeline is a Google pipeline. You do it in GKE. And here you can implement it in an afternoon, because here you have a stack driver and can push every result of the scanning into a BigQuery, and then you have the role of the auditor. The auditor only sees what is in BigQuery, and the developers cannot change the results in BigQuery. So you have implemented a very simple audit process with a handful of mouse clicks. This is possible on the cloud platforms. If you are allowed to put your application into a public cloud, this might be the easiest way to improve security quite fast. It also works with Azure DevOps and in Amazon and in other public clouds. If you want to do it, if you have to do it completely on your own, bare metal, then it might be you only need an Elasticsearch. Elasticsearch also has role-based access control, and then you can guarantee that the results cannot be changed by developers. And what we here did is we have a DevOps process, so the developers are allowed to enter container with pharmacy database information, which means this is your recipe or your recipe, and then based on the recipe and the pharmacy you get, you can quite simply conclude which diseases you have. So this is highly GDPR compliant information, and this has been accepted. So this works, but this needs further control. Auditability is one of my goals in every environment. We see audits, yes, we have 2,000 virtual machines, and now the auditor picks 5 of them and looks into them in detail, and yeah, here is the audit results. This is not an audit. This is a classical way, everywhere it is done this way. It's a lottery. And it should not happen this way. Everything should be checked automatically. So the demand of auditability is the first step we have here in our environment. The security audits you see on customer sites by this flawed process, these are all lies. Auditability must be planned as developers plan the testability of their code. So if you write code which is not unit tested, you don't get testable code. And the same is in infrastructure. And the honest auditors tell you, yeah, we find 5% of the vulnerabilities. And sometimes people are lying directly into your face. Normally, I'm a friendly guy, but this time I really get angry on that. So security models, this might be known. Effectively, this is the standard security model in critical infrastructure. It's a medieval castle design. But with Kubernetes, this is your battleground. Try to find a moat or a wall. Okay, this looks more, sorry for the military pictures, this looks more, the carrier in the middle is completely vulnerability and must be protected by an entire fleet of other ships. Otherwise, it would be an easy target for anything. In the future, this talk is older than the current wars. We will see more agile and more aggressive attacks on everything. And now we go through all the application containers down to the service account. And one missing thing, what I tell the people is, you have to identify what is your control plane. The network people think the control plane is their whatever Cisco or Juniper or F5 network thing. No, it's not. In our software-defined environment, it should always be the Git. And this means here, everybody thinks, yes, the president is in control of the nuclear weapons. No, the engineer who installed the red button is in the real control. And we have to communicate this. And this means, for example, I'm skipping a little bit, we need to fix the architecture that you really know what you are doing. The network policy is one part, but if your application is not capable of using network policies because you have one container who is doing the syscontrol call, then you have a direct path, so you have to separate this first. The architecture is part of the analysis. You have to analyze your architecture if it can be secured first. Signing is a big thing. Sigstore, I just tell you this is the path of signing application. Sigstore is available, GitLab, GitHub, so you can train it quite easily. Another thing we have is a minimal air-gapped environment. I did this, I have two customers in Brussels. The one you know and the other is Elia, also 4 letters, who is the transmission grid who runs the transmission grid in Belgium. You have a typical harbor, do the scans inside the harbor, and you need a Git, because we want to do GitOps, so you need to have a small Git. And for convenience, we use Argo CD, and we could simply activate the signature checking function. Then you only, on the left side, you get signed images. One thing about this Zero Trust, I don't trust the zero in Zero Trust, because it always collects the things which you don't know. What you need is on every level, you need an analysis of your trusted compute base. This can be your Intel enclave, if you don't trust the memory. On the operation side, it might be that you have to apply zero admin or zero privileges rules. So the administration staff is not allowed to change or enter a running node or container. The application staff is only allowed to create and delete clusters and nodes in the cluster. This is a big limitation. I normally here is the step where I take away SSH, because SSH is notoriously insecure, not in the protocols, but in the way it is used, and we have some kind of clashes here sometimes, but we can resolve this. And if you go on the lower level, on the CPU, GPU layer, you get now enclaves, you get trusted boot. eBPF can be blinded completely, so I don't believe in Linux kernel security, because there was an exploit of you overwhelm eBPF with messages, and then all these mechanisms of detecting vulnerabilities don't work. So there is another approach at the moment to mount a microkernel below the Linux kernel. Nova is the name, it's quite new. and it is in the it will be automatically proven. But this means that you have a microkernel which is aware of Linux kernel container and the Linux kernel namespaces. This is available in the future. Conclusion, yeah, it looks like we have a lot of work to do. First step is try to automate everything, that you get rid of all the manual flaws. I mentioned some tools. Really, as in DevOps, it's a mindset over tooling approach. Do a strategy first. Your management will not allow you to play around with the securest environments if you did not convince the management first. You can do all with existing tools. You have a lot of complex tasks, and then try to raise your skills on a level where you understand what you are doing, which is sometimes what I've seen in the world, because people are sometimes too young. So young developers are not responsible for 25 years of SQL injections, obviously, but they have to understand it. So this is the next thing, upskilling your team to a level where everybody understands it. Thanks, and here are some links. My trainings are on GitHub, some container hardening, management clusters, other things. So I'm available. Thanks for your attention.
Thank you very much. And thanks for your good takeaways. I think those points we really be aware of, all of us. Do you have any questions to Thomas?
Yeah.
Yes, there is one. Oh, there are many. Okay, that you were the first one. I will go over to you and give you the microphone. Give me 1 second.
Hi. Can you please give some examples of how SSH is being misused?
SSH is, the example was one of the founders of OpenSSH. There is a talk about this. Has left the company, and after he has left the company 5 years later, his public keys was available on 150,000 servers. So the key management of SSH is a flaw in nearly every company. Active Directory is not the place to do it. Puppet is not the place to do any configuration management. So SSH in a Kubernetes environment is not needed if you have a zero admin approach. But then you have exactly no debugging features on your node. So you have to automate first, and then you can remove SSH. This is complicated. Sorry for the SSH fans.
Yeah.
Hello, I'm about the point that the strategy is more important than tooling. So the security of runtime level is quite vendor-locked, I would say, now. So if you choose strategy of some, I don't know, vendor-locked supplier of runtime security, you kind of in situation when you just follow what your provider gives. For example, if you use gvisor, then you are locked into Google. If you use I don't know, AppArmor, maybe into SUSE. Or in general, I'm talking about how to avoid vendor locking.
You should always have a plan B. Vendor lock-in is not a problem by default, but it should be addressed as a risk. So you have, for the management, yes, we lock into Google, Amazon, whatever. But this is a risk, and then if we have to leave, we have exit costs which we have to address, and it just has to be in a plan that if you change your platform, then you have additional costs. And try to keep it as small as possible, but sometimes it's not avoidable, or it makes it quite easy to get some solution up and running in one cloud, and then you have a vendor login.
I think you can ask further questions to Thomas later during the day. He will probably will be available. So I have the feeling that this topic has a lot of discussion areas. So maybe later than during the networking part. Thank you very much again, Thomas.
Thank you.
Small applause for you. Thank you.